All right, hello Southwest weather class. This is going to be the lecture to go along with the week of March 30th, although I'm actually filming this here on Saturday night and using, yes, a blurry reflection from a window because I'm going to try a different technique tonight. So I'm going to try to move so I don't get you guys too motion sick here. All right, the whole point of tonight's class is just to go over and reinforce everything we have learned about mid-latitude cyclones, because this is weather. This is everything we have been working toward all year long. We're putting together all those elements of weather, from temperature and air pressure and precipitation and winds and air masses and everything like this to actually make the weather. So the mid-latitude cyclones that we talked about last week, we're going to be talking about in even more, detail and just going over and over again because it's explaining what's happening. And tonight was a perfect example of a lot of things we're going to talk about. All right, so we had some, heavy rain that came through, around, I don't know, what is it, 9 o'clock, 8 o'clock, whatever it was. There was some bad weather to the west of us earlier. I think it was around 5 p.m. I heard a tornado had hit Jonesboro. I hope everyone's okay. I have not seen reports of damage or casualties or anything like this. But that, the few hours later came through us. It is past right now. It's still sprinkling out a little bit, but temperatures have dropped. It was very warm today and muggy and has been. But anyway, so here we go. Here's a picture yet again of one of those mid-latitude cyclones. Remember, cyclone is just another name for a cell of low pressure. And you can see the cell of low pressure here. And we talked about how these secondary cyclones set up, go through about a 1 to 2 week life cycle and then die. And this diagram right here is just showing that again. Right up here at the top is showing at the polar front where we get a kink and where we get cold air starts to move down south. Warm air swings up north and it gets birthed. The big diagram here is just kind of a very middle mature stage that goes on. And then eventually, as that low moves across North America, makes a swing back up toward the northeast, it'll eventually, the cold front is going to catch up with the warm front and it's going to occlude. All right. Just to remind you again, difference between cold front and warm fronts is dealing with the big air masses. So we have a cold air mass, the CP, continental polar. It's going to be much more dense. It's going to act like a bulldozer and it's going to push up warm air that is in front of it. Here we have the slope of discontinuity, that three-dimensional boundary between the two air masses, the cold air mass and the warm air mass. That's right here. And if this slope of discontinuity is quite steep, it's going to cause adiabatic cooling as that warm air rises and can often lead to storms that goes on. Now remember, the other end of this is the warm front, where the warm air is running up the back end of some cooler air. Here the slope of discontinuity is much less steep. It's a much more gentle slope. And so we still get adiabatic cooling going on, but it's not quite as rapid. It's not as high. And so we tend to get stratus clouds instead. And, these do bring rain, but they usually don't bring the more severe weather like we saw tonight. So I want to swing back up here again. So in this scenario, all right, what you always want to keep in mind is when you've got a mid-latitude cyclone coming through again, that's the actual low pressure center itself. All right, and with its attached cold front and the warm front. So all this area right down here is the warm air. All right, it's our maritime tropical warm wet air. All right, and you're going to see this pattern again and again and again. Behind the lows are where you have the high pressure, which is the cooler, drier air. All right, that's why it's high pressure. You guys remember that. High pressure is colder air and it's sinking. You don't get clouds. All right. So, key thing to keep in mind, and I'm going to show you a diagram of how these lows move across the country. All right. So they're usually birthed up kind of like, they can be up here in Canada somewhere around the polar front, and then they sweep across and do this. And the stages of the cyclone, when it starts out very wide open and then when it starts to close up, is all occurring as it's moving. Now, the average speed of one of these cyclones is about 23 miles per hour, and as it moves across. But of course, every single storm, mid-latitude cyclone, is unique. Some move faster, some move slower, some speed up, some stop, some slow down. Some, it's extremely variable, and we'll see examples of that and talk about that here in just a little bit. But let me show you the diagram of how it moves across the country. So here we go. All right. So here's one that has formed. All right. So you see the cold front, you see the warm front. Tennessee is like right in the middle of the warm air in this scenario. All right. With pretty much this probably looks very similar to what actually happened tonight. So this would have been a shot about probably 4 this afternoon. It would have looked very similar to this. And then as it moves across, all right, you see in this instance, the cold front has moved past Memphis down in the southwest corner of Tennessee, all right? And then it continues to move on. The cold front is moving faster, catching up with the warm front there, and eventually it occludes. Now, as I go back in time, notice that the low itself has also moved a bit to the east. All right? So, in each picture, it's a little further to the east when that goes on. All right? So, again, here's the diagram I'll keep coming back to because it's lovely color-coded. All right, I'm going to show you some other examples, other weather maps. All right, so here we have another one, exact same scenario. All right, we've got the low pressure right here. You've got the shark teeth here for the cold front. You've got the camel humps for the warm front right here. This is going to be the warm air mass. So again, Tennessee in this particular case, Florida, Mississippi, Alabama, these guys are in the warm air, all right? So we know that clouds and thunderstorms can come just in front of the cold front. So you can see in this weather map, they are predicting thunderstorms right there in front of the cold front. So this area right up here, all right? Now we also know that we can get clouds just from a low pressure center itself, because air is rising up underneath that low pressure, all right? It's rising. And so you have clouds right at the low pressure area itself. And of course, you can also get a quite wide band of clouds in front of the warm front. Okay, that's always the possibility that goes there. All right, so if you're in this area right here, so like if you're in Missouri on this map, you're really screwed because you've got combination of the low pressure center itself, you've got cold front coming in, you got warm front, so yeah, you're gonna have funky weather for quite some time. All right, now let me show you what this looks like from a satellite view. You can see the clouds. You can easily pick out these systems based on the cloud formation. So you come down here, and here's the exact same scenario, all right, that we saw up here. All right, so I'll take it up so you can see it both at the same time. Now you notice this makes a comma shape. That's what you always want to look for on a satellite map with the clouds. All right, it always looks like a big comma. Here is going to be the head of the comma. Here is where the low pressure center is the center of the low pressure. All right, you can see this very distinct break between the white clouds and the black, which is clear skies. All right, that's where the actual cold front is going to be, right close along to that. Of course, we got, there we go, got lots of clouds right here at the low pressure center itself. We've got a wide band of clouds up here where the warm front is. And in this case, we've got a narrow squall line right here. We've also got a secondary squall line a little further out in front of it right here. And then these are just, this case, the clouds have all done up. All right, you can look at that. If you want to pause it or anything like this and look at this longer, you can do that. But again, notice the comma shape. So let me show another example. You're going to still see that same comma shape. So, all right, so there's a close-up again of yet another low pressure center. Let's see. I'm trying to, where are we in this? Okay, so there's Louisiana then. So we're about right here. That's where Memphis is on this. But again, you got the low in the center, cold front, warm front. This is going to be the warm air. All of this is going to be the cold air. And when you look at the satellite photo, there again is a comma. This one's, it's still the basic comma shape. So here's where the low itself was. All right, and all the clouds associated with that, blending in with the massive stratus clouds, which look like a big blanket that are associated with the warm front. And then here you can see some very distinct, just narrow bands of cloud. All right, these are more broken up, so it's not near as heavy a clouds right here. But right here is going to be your main squall line. And that's what a squall line is, and it's a line of clouds here, which means the cold front itself, that leading edge, is going to be right around here. All right, and you can see here's the cold, dry air, because no clouds, no adiabatic cooling going on. The air is stable here, but every place you see clouds, that's where air is unstable, where it is rising. And you can get, anytime you've got unstable air, if the humidity conditions are enough, you can get clouds. And of course, not every time you get clouds are you guaranteed rain. All right, again, it just depends on the absolute humidity and the temperatures and dew points and everything like this. But let me show you yet another example. All right, this is from a different part of the country. This is the Northwest. All right, so we've got Washington and Oregon. This is going to be British Columbia, Canada. Alaska's up here at the top. All right, but again, it's still a low pressure center. All right, this one, it's starting to occlude right up here. This is on its death throes, but we still got the cold front and the warm front. There's not a whole lot of the warmer air mass that's here, but yet again, all right, up here is kind of the low, or this area right up here. This is something else going on over here. That's off of the small map down over here. But here, this kind of swirly section, that's where the low is. You got all the clouds from where the cold front is occluding with the warm front. But what's left of the cold front is going to be right around over here. All right, you notice you got some real high, spotty little clouds up here. These are just hanging around at the top of the colder air mass. But this would be the squall line associated with the cold front. All right, the low up here, there's obviously not a whole lot of moisture, even though, yes, we're over the ocean, but my guess is that the air is quite cool, and it's probably not holding a whole lot of moisture. So it may not be reaching, a whole lot of dew point that is up here. All right, so that's just another shot that goes on. What I'm going to do is swing over. So you might want to close your eyes for a second so you don't get motion sick. And I'm going actually to our local weather page. So this is tonight. This is easy to get to. It's easy to remember. It's weather.gov/MEG. So that gets you to the Memphis area. All right, so I'm going to scroll this down. I want to show you on these maps. All right, there is the radar, which shows the rain. That's not just clouds, it's rain, but you can see the remnants of the squall line that came through earlier. All right, it's now over. I'm trying to see this. In fact, I will click on it. Let's blow this up a little bit, and of course you're blocked. I don't want to run this plug. It's not going to cooperate, of course not. So we'll just zoom in here a little bit. But anyway, the dark red is the heavier rain. So the squall line is not, it's a lot more formed right, here we go, right around up here, which I think that is like Jackson area that's getting probably hit right around now. Right now, we're getting ready to get the clear skies. I know it's already cooler out there quite a bit. It was quite warm today. I was out and about in it. But if you go outside now, it's much cooler, and pretty much this rain you can see is moving, moving out of the way. Now you notice how this is moving. Notice that this is on a loop and it's moving this direction. Okay, so it's sweeping across from the west to the east, but with us it tends to go more of a northeast direction. All right, so that's why our weather, actually, we look to Little Rock. We're the storm track that Memphis is on. It comes through Little Rock down here. First comes up through us and then goes kind of up through Jackson's and Dyersburg and goes on. That is our, that just popped up right down here. That is a tornado warning. We will talk more in detail about tornadoes. So yeah, hope you guys are in North Mississippi. All right, I'll have to check in on that. Hopefully that won't touch down. All right, but over here, this is what we want to look at. All right, I'm going to click on this and make this bigger. All right, so here is today's forecast. So you see the low. All right, this was from earlier today when the cold front was still actually over in Oklahoma and Texas. All right, here was the warm front. Now the warm front came through us on, I believe it was Wednesday. If you guys remember, it was all cloudy on Wednesday, and then the temps went up into the 80s. And Thursday and Friday were gorgeous out and were warm, and we all got our shorts out, and I was outside barefoot and working in the yard and everything like this. That's because we were in this warm section. But the forecast has been, of course, for today, it was supposed to be mostly cloudy and chance of rain. Now, even as of last night, the rain was supposed to be hitting much earlier today. And then you checked on the forecast this morning and it's like, oh no, the rain's not supposed to come till after 4 p.m. And by the time it actually hit here was like around 8. And that's the whole nature of weather forecasting. Weather forecasting is based on, let's see where things are right now. Take a picture of it. See where the low is, where the cold front is, where the warm front is. Let's see how it's moving. All right, how fast is it moving right now? We know the prediction, this is probably gonna kind of swing up this way. All right. And it's, however fast when this was moving, you make your predictions. But the weather has a mind of its own. And so 6 hours later, you realize it's slowed down. Or perhaps the movement has sped up, or it's gone a little bit further north than you thought, or a little bit further east, or a little bit further south. That's going to make your trajectories off, and so you have to change your forecast. To be honest, forecasting more than 24 hours in advance is just a pure crapshoot, okay? You're going to find the horoscopes in the paper are going to be more exact than forecasts that go 3, 4, 5 days in the future. There's just no way of knowing what exactly is going to happen, especially for us here in the battle zone. Remember, this whole area in North America, even going all the way up into Canada, all right, is the battle zone, where we've got these mid-latitude cyclones coming through all the time, and you never know what's going to happen. Now, here is tomorrow's forecast, which is Sunday. So the cold front will have moved all the way through to Middle Tennessee. So Nashville's probably going to, expect to be getting their rain tomorrow morning. All right. We are in the under the influence of the cold air mass, the high pressure. So tomorrow is supposed to be gorgeous, okay, very clear, and temps are only a high of about 70. So a good 10 degree or so jump downwards. More evidence that a cold front came through, all right. You can see that the low is starting up in this area right up here. All right, I'll use this better. Is starting to occlude up, all right. And let's see what it says for Monday. So here's Monday, whoops. All right, so that original low is way over here now in New Hampshire. Here's that original cold front, is completely off of the coast, swinging over here. We're under high pressure, all right? And if you look right here, we got another low that's coming in. And there's obviously another low right up here that's behind all the data, all right? But you can see the cold front and the warm front. So there's going to be another low forming. This time of year, we have multiple mid-latitude cyclones in multiple stages of birth, midlife, and death going on all at the same time. And this is the reason we keep having the up and down and up and down and up and down weather while we have cold, while we have warm. All right. The next 2 days, Sunday and Monday, and it's supposed to be, highs in the 70s, and it's supposed to get back down into the 40s at night, as opposed to, I think it was like, the 60s last night. I know I was hot upstairs. Had to turn my air conditioning on, and now it's going to have to turn it off and get my comforter back out again. All right. So these are always, again, these are forecasts, and trust me, these are going to change. All right. I'm going to go back. In fact, we're going to look at the 5-day forecast, which I go up to here to click on that. All right. And pull it up. All right, and so here's the rest of the night. Now we should be pretty exact with this. This is just not even a 12-hour forecast here. So tomorrow's sunny and 70. Sunday night, clouds are starting to come up again. 52 as that low gets in, closer to us again. All right, and then here we've got thunderstorms coming through. All right, high of only 64 on Tuesday. So another cold front is coming through on that. All right, so we're expecting showers with that. Some of them could be worse. And then by Wednesday, see, high of only 63, lows of 46. All right, so now will this actually come to pass on Tuesday, Wednesday? Who knows? Check back tomorrow, it'll change, more than likely. It might end up being Tuesday night that the rain gets here, or it might get here earlier, or you never know what goes on. All right, but this is where you can check and see. So again, close your eyes while I swing across again. I want to remind you guys, all right, that again, every single cyclone is very different. All right, so I'm just trying to show you some different examples of each cold air mass that comes through, all right? They're going to have different shapes. It's going to be dependent on the difference in temperatures between the two. So like this one is your very stereotypical looking one with the very steep slope of discontinuity in the front here, with about a 10 degree. But in this scenario, guess what? We didn't get any clouds. If this air happens to be dry air for whatever reason, even though it's lifted up and cooled off adiabatically, if it doesn't reach the dew point, you're not going to get clouds. That it's not guaranteed that you get clouds with every single cold front that comes through. Here's one I tried to make it kind of made me like tonight was, all right, so where we had 80-degree weather, all right, here was again, 55-degree weather coming through, so a very steep slope of discontinuity. So we got actually 2 rows of squall lines going on with rain and storm and severe weather possibly. And so we're like about right here now. All right, still got a little bit of rain, but pretty soon we'll be over here in the clear. Of course, what we'll see sometimes, especially in the summer, that happens is that cold air mass is not really very cold at all. There's not much difference between the air that it's invading. This is still a cold front. It's still, 90s, colder than 95.
But here, slope of discontinuity, even in the front, on this leading edge right here, is not very steep. And so, yes, there's a little bit of adiabatic cooling that goes on, but often, you won't even notice that this passed through. All right, and that, we'll see that's more of a summertime phenomenon that goes on. All right, so in the spring and the fall, wintertime, here in Memphis, we're getting a lot of this frontal precipitation. It's all these mid-latitude cyclones that are coming through, brings our rain. But what about the summer, when we have usually more of a case like this? All right, where's all of our rain come from then? Well, I'm going to show you a picture. It's not of Tennessee, but it demonstrates what's going on. When we have warm temps, all right, we can still get convective thunderstorms. All right, if you guys will remember, I'm going to actually swing back up to this. On the diagram, that I3 diagram that you did last week, we talked about labeling areas where you get convective thunderstorms. Where that's going to be is in your warm areas. All right, so this is how we can actually do weather forecasting. So in this one, I'm going to use Wichita, which is right smack dab in the middle of the warm air mass. Okay, Wichita's in between the fronts. So it's just a normal, probably a nice day. All right, they're too far away from the cold front to be getting squall lines from the cold front. The warm front's already passed through, all right? So it's just a normal day for Wichita. But if it's warm enough, they're gonna get just regular convective heating. The sun's gonna be shining, it's gonna warm up the ground, all right? Then the heat's gonna rise up from the ground, and you can get little afternoon thunderstorms that pop up in these areas, all right? These are not squall lines. These are individual little thunderstorms that live and die, or you could just get a bunch of little poofy clouds, those cumulus clouds, those fair weather clouds. So here is a shot of Florida. All right, so there's the map right there. So here's the whole peninsula of Florida. All right, and you see a lot of clouds, but they're all, looks like little polka dots of clouds. You don't see the comma shape or anything like this. And in fact, you notice the clouds are only over the land masses. All right, you can actually make out the whole peninsula of Florida very easily here. Those are all cumulus clouds, little convective clouds. Some of them may eventually in the afternoon build up into cumulonimbus, which are the thunderstorms. But most of these are just little poofy cotton ball bunny tail clouds that are doing around. Why do you see most of them over the land? Well, this is probably a late afternoon shot. The land's going to get warmer than the water. So you're gonna, it's hotter. So that's where the air is rising and you're getting your adiabatic cooling that goes on. And of course you're reaching the dew point and getting all these little poofy cumulus clouds. The water is going to be cooler, so the air is going to be stable or sinking all around over here. Now, if you are familiar with Florida, you may already know why we have this hole right here, why we don't have any clouds. If we don't have any clouds, that means the air is stable, all right? So for the air to be stable, that means it has to be slightly cooler. So what do you think is probably down there that would be slightly cooler than the rest of the peninsula? All right, yes, there's the big water, okay? And I've gone totally blank on the name. All right, whoever's been to Florida recently, I'm supposed to know the name of this big giant lake. Okefenokee? No, that's the swamp. Anyway, there's a big lake that's down there. All right, and you can easily see where that is because that lake is going to be slightly cooler because, again, we know water does not heat up as fast as land. So that stays slightly cooler. The air stays stable above the lake, and we don't get the clouds like we get everywhere else. But we get, and especially in the summertime or anytime, you can tell how well the humidity is. So this is going to be a pretty muggy day on Florida when this was taken, because there was obviously a very high relative humidity. It doesn't take a whole lot of lifting of the air for it to cool down to the dew point and form all these little cumulus clouds. All right. So hopefully, that's pretty much it. All right. This is weather in a nutshell. The mid-latitude cyclones. All right. And then with us, with our large battle open area all between here, we can get cyclone after cyclone after cyclone that comes through. And especially here in the springtime, when we've got the biggest temperature difference between the cold Canadian air and the warm Gulf of Mexico air. And the bigger the temperature difference is, the steeper your slope of continuity in the front with the cold front, and your higher potential for stormy weather. So that's when we usually see most of the storms. All right. Now, again, going back to this type of example, you can find examples of this in your textbook. You can Google it, examples if you want to have a more stable, static copy of this type of thing. But this is how we do weather forecasting. All right, so going back to Wichita, right now, temperature is going to be warm. Skies are probably going to be clear. You might have a few, little poofy clouds. All right, but the forecast, we know what's coming. We got a cold front coming. All right, this is sweeping in. So within the next 24 hours, the forecast for Wichita is going to be a chance of, good chance of rain, possibly thunderstorms, and then the temperature is going to drop. All right. For Denver, right here, Denver, right now, the situation is clear and cold. Cold front just went through for them. They probably might have just had some storms. Tomorrow, they're going to be back here, all right, 24-hour forecast. They're going to be under the influence of that high pressure. So tomorrow is going to be probably colder and clear. All right. For Memphis, okay, here's Memphis right here. Right now, we probably have some clouds going on, all right, because we're right at the stationary front. We're in cooler air, all right, but there might be clouds. I'm not 100% positive. We may have clear skies here. All right, maybe down here in Arkansas that has got the clouds. Just depends on where the stationary front stays, because the warm air is going to be running up here. But as long as this is not moving, we probably don't know. But as soon as it moves, so it might be a chance of rain, tomorrow. All right. Or not. This is one of those ones that, they might say 50% chance of rain. Depends on what the stationary front does. All right. Columbus, way up here, they're in cold air. They're in clear air. And that's pretty much what it's going to be tomorrow as well. All right. Now, 2 days, they know that the warm front's going to be coming their way. And so maybe in, their 2-day forecast, rain will be a higher likelihood. All right. So it's actually not that hard. You can just, figure out where you are. We know the direction. Okay. We know the pattern that the lows follow. All right. And so, again, weather's coming from the west, moving toward the east. All right. So it's very easy to pick out what the current weather is if you can look at the map as it is right now, and then make your predictions. Okay. In your lab book, hold on a minute. I forgot to pull out the lab book, so I'm going to, again, close your eyes so you don't get sick here. There is an exercise. Oh, look, blood pressure kit. Woohoo! Here, you can look at hubby and where is the piece I am looking for?
Hang on. It's not in this, my page. I've got a page. Hang on. I gotta swing over someplace else. So it's gonna go black here for hang on. I'll go over here. I'll show you my cat. There's Corey cat again. Say hi, Corey. Hello, Corey. All right. If I could only figure out how to pause on these, would make all our lives easier. So there is an exercise for you to practice in your lab book. Here, we can look at Corey. You can see her ears in the basket while I'm looking for this. Here we go. All right. It's I-8 in y'all's lab book.